Okay, in this video we look at compression, the last bit of topic 1 for CIE 9618. We looked at how we can store text, pictures and sound on a computer, and now we look at how we can compress it. So compression means just reducing the file size by whatever method. We're trying to make the file smaller in terms of storage. This saves storage space, so your solid state drive, your hard drives and everything can store more files, more things, if those files have been compressed. That makes better use of them. It also reduces the time it takes to transmit a file over a network and use less bandwidth on the network. A small file is faster to download, so for things like video streaming and file downloading, then compression is really helpful. Lossy compression is a type of compression where we permanently remove some of the data. We get rid of data that is somewhat unnecessary. You may not notice it at all if it was taken out, so you can reduce file size but still maintain perceived quality. Obviously, if you compress too far, you will definitely start to notice that degradation in quality. It's commonly used for things like images, audio and video, with various protocols used like JPEGs, MP3s and MP4s. Lossy compression gives smaller file sizes than the other method, which is called lossless, and it's really good for things like web use where quick loading and downloading is important. The disadvantages of lossy compression are that you can't restore the original file. You've permanently lost some of the data. And like I say, if you keep compressing with lossy over and over, or if you try to compress too much, you will see degradation in the quality of the image or the sound, whatever you're compressing. With lossy compression, you do get very good compression rates. For example, a 5 megabyte picture could go down to 0.8 megabytes with only a slight reduction in the quality. Now, lossless compression is defined as the compression where there's no loss of data. The file can be decompressed back to the original exactly. So you've not lost anything and you've got an exact perfect copy of the original file again when you decompress it. Commonly used for images, certain kinds of images like PNGs and GIFs can use lossless compression. Documents, so zip is a lossless compression, and audio FLAC files, again, they're lossless compression. Lossless compression is perfect for when accuracy is absolutely essential. So if you're doing something like a text document, writing some software code, doing a spreadsheet, then you need those to be absolutely as they were intended originally. You can't lose bits of data from there, or numbers or words, code, without disastrous effects. So use lossless compression. Disadvantage, you don't really get as good compression ratio as you do with lossy methods, but you still can get good compression. So text document, for example, 100 kilobyte text file, you might zip that down to 40 kilobytes and you've lost nothing. You can get back to the exact original text document. One of the techniques for doing lossless compression is run length encoding, or RLE. So the idea behind this is you try to identify repeated or consecutive repeated values, and then you just store a single value and how many times that occurred, i.e. the count. So this works best with things like images or data where there's large blocks of identical values, i.e. in one place consecutively. So for example, we've got this text where there are repeated groups, A, B and C get repeated. So instead of storing all of those individual characters one at a time, we actually store a count and the value. So in this case, 5 A's, 4 B's and 6 C's. And if there are repeated groups, large blocks like this, you can save an awful lot of data that way. It's very simple to implement. It's effective for certain kinds of images and files where there's big blocks of color that are the same. However, it doesn't work well for complex images like photorealistic images. Most sort of pictures don't work that well. So it can't be used in every place. So compression, different file types, just recapping. Text files, you have to use lossless. Compression techniques can use patterns in the characters of words, like run length encoding. Bitmap images, you can use either. You can use lossy or lossless. Vector graphics, you need to store those lossless because the drawing list, the object list, is all stored with mathematical expressions of the shapes, and you can't change those. You can't lose bits of those. If you were using lossy compression, you wouldn't be able to work out what was going on. It would be incorrect. And then sound files, you've got lossy, for example, MP3, but also lossless, like FLAC and WAV. So, for example, if you want an absolute perfect stored archive or version of a sound file, then you would use a lossless compression. However, when you're using it sort of on a daily basis, like storing it on your music device, your phone, then lossy is better. So to choose lossless or lossy, you use lossy when you want a small file size, when that's really important. For example, when you're doing things on the web and you want it to be fast. You use lossless when accuracy is really important. Some key points to remember. Compression reduces the file size and speeds up transfer. Lossy compression removes some data permanently. Lossless does not lose anything. Run length encoding is a type of lossless method. Run length encoding is a simple lossless method for compression. And the choice between these two, lossy and lossless, depends on the balance between quality and file size, which is more important. Some formats like zip compress multiple files in one go and then create a single archive. Okay, that's the end of topic 1.